alien abductions were fascinated by the idea of extraterrestrial life. Now scientists have found the strongest evidence yet that a planet 124 light-years away could be home to life. The red alert from NASA was unlike anything the world had heard in decades. The James Webb Space Telescope, humanity's most advanced eye in the cosmos, had been surveying the depths of space when it detected something truly extraordinary. An object, massive and dark, drifting closer toward Earth with a velocity that defied initial expectations. Alarms rippled through control rooms as data confirmed the object was not a distant curiosity, not some celestial remnant moving harmlessly along its orbit, but a body approaching within a proximity that demanded immediate attention. The Webb telescope, designed to peer billions of light-years away into the infancy of the universe, had instead captured an imminent threat much closer to home. The discovery began with faint distortions in the light spectrum. Webb's highly sensitive instruments picked up a faint shift against the background of stars, a movement that was subtle but persistent. At first, researchers thought it might be noise or interference. But frame after frame, the object revealed itself. Dark, irregular, and far larger than anything its trajectory should allow near Earth. It wasn't merely an asteroid grazing by, nor a harmless piece of debris. This was something different, a colossal object of unusual density and reflective properties. Its surface absorbed most of the light Webb captured, giving it a ghostly presence. Like a shadow moving across the void, NASA quickly convened its top astronomers, orbital analysts, and emergency response teams. Their first task was to calculate the object's trajectory. The Webb had tracked it across several points in space, and with each refinement of the orbit models, the reality grew more unsettling. It wasn't moving in a neat elliptical arc like most asteroids from the belt. Instead, its path seemed irregular, wobbling as if influenced by forces that conventional equations struggled to model. The possibility that it might be a fragment from a larger celestial body was raised. Yet, even then, the behavior didn't fit the usual profiles. The object appeared to have an internal structure or composition that was altering its spin and drift, sending it along a path that pointed alarmingly close to Earth. The magnitude of the discovery lay not just in the fact that something was approaching, but that it had eluded detection until now. This object had not been on NASA's catalogue of near-Earth objects, nor had any ground-based observatories flagged it. Its dark surface and erratic path had made it nearly invisible against the blackness of space. Only the extraordinary sensitivity of Webb's instruments had managed to pick it out in the vast ocean of stars. The revelation raised difficult questions about how many other such objects might be lurking unseen until they are dangerously close. The very system humanity relied upon to safeguard its planet had just been blindsided. Astronomers pored over Webb's infrared data, trying to extract every possible detail. The reading suggested a body many kilometers in diameter, far larger than the meteor that exploded over Chelyabinsk in 2013 and many magnitudes greater than the Tunguska event of 1908. Those historical impacts were devastating in their own right, leveling forests and injuring thousands. But this was different. This was a scale that could not simply be shrugged off as a localized disaster. Its dimensions pushed it into the category of planet-threatening, a reminder of the same kind of impacts that reshaped Earth's history and ended the reign of the dinosaurs millions of years ago. What unsettled NASA scientists even more was the object's unusual makeup. The Webb spectroscopic analysis showed a strange blend of elements. It wasn't a typical iron-rich asteroid, nor a frozen comet nucleus. Instead, traces of rare heavy metals appeared in its spectrum, along with minerals not commonly found in near-Earth objects. This hinted at an origin far from our planetary neighborhood, perhaps ejected from the outer reaches of the solar system or even from interstellar space. That possibility alone was staggering. An intruder from beyond the protective cocoon of our planetary system now heading directly toward us. The implications rippled through the scientific community. If it was interstellar, it bore echoes of Oumuamua, the elongated object that had passed through the solar system years ago and sparked debates about its nature. But this was no fleeting passerby. This object was not simply traversing space. It was on a collision course. The thought chilled researchers who understood the scale of what was unfolding. If interstellar, its velocity and trajectory might make it harder to deflect than anything previously imagined. Earth's defenses, still in their infancy with experimental missions like DART, were not designed to contend with something of this magnitude and speed. Inside NASA's control centers, tension rose as projections grew more refined. Supercomputers ran endless simulations, mapping possible paths and gravitational influences. Each scenario carried uncertainties, but many converged on the same dire possibility, an impact window that fell disturbingly close to Earth's orbital position. Analysts debated the margin of error. Was it tens of thousands of kilometers, or could it narrow to a direct strike? The smallest adjustment in trajectory could mean the difference between a near miss and global catastrophe. As word spread internally, the language of red alert was formally invoked. This was not a casual warning nor a scientific curiosity. It was the highest state of vigilance, a recognition that something with potentially world-altering consequences had entered humanity's sphere of awareness. From that moment, the object was no longer an astronomical anomaly. It was a crisis. The public, of course, had not yet been informed. Within NASA, debates raged over how to communicate such a discovery. Transparency was vital, but so too was caution. Announcing the presence of a colossal, fast-moving object without definitive answers could trigger panic. Yet, silence was equally perilous, for the truth could not be hidden indefinitely. Every major observatory across the globe would soon detect it now that Webb had identified its position. Collaboration was inevitable, and secrecy was fleeting. Beyond the scientific urgency lay the haunting reality of what this meant for civilization. Humanity had always known in abstract terms that space harbored threats. The idea of an asteroid impact was woven into textbooks and documentaries, often treated as a distant theoretical possibility. But this was no longer theory. This was an object, enormous and real, bearing down on Earth in real time. The fragility of our world had rarely been so exposed. The scientific community recognized the dual weight of the discovery. It was both a profound opportunity for study and an existential danger. The Webb telescope, designed to peer at the birth of galaxies, had turned its gaze to something that could alter the course of life itself. Every byte of data it collected became a piece of the puzzle. Size, shape, composition, speed. Each new detail tightened the margins of understanding, bringing scientists closer to predicting what might happen when this intruder reached the vicinity of Earth. The unusual reflectivity pattern suggested the surface of the object was jagged and irregular, possibly porous like a comet, but far denser. Some models showed it tumbling chaotically with sunlight creating subtle accelerations on its uneven surfaces. These slight shifts, known as the Jarofsky effect, made its trajectory harder to pin down with precision. Yet, the same irregularities also meant any attempt to deflect it would be incredibly complex. A strike on one side might splinter it unpredictably, multiplying the danger instead of averting it.